This video is going to look at radian measure. And radian measure, or radians, are now a new way that we can measure angles. So far we've been looking at degrees for most of this time. When we're looking at angles, we're now going to explore what we call radian measure. So let's say that I've got a circle here, okay, and I've got my center point, and I'm going to create a bit of a sector here, which is going to run from point A down to point B. Okay, then of course I've got my radius, so my radius is r units long, okay, and I've got my arc length as well. I've got an arc length here which runs from A around the circumference to B, and that there is my arc length, and I often give my arc length the letter L. Now, if I say that the arc length, I've actually created this sector in such a way that this arc length is equal to the radius, then what I've created is I've actually created an angle in here which is equal to 1 radian. Okay, so if my angle was a little bit too big there, if I made my sector a bit too big, then my arc length would be too large. It wouldn't be equal to the radius anymore. And likewise, the same would go if I made my angle a little bit too small. But because I've made my angle so perfect here that the arc length is the same length as the radius, I've actually got an angle of 1 radian. So for example, if I was to throw some numbers in to kind of make it look hopefully a little bit nicer, I've got my sector here which I've created. Let's say that this radius here is 3 units long, so we're 3 units long down here. And let's say that this sector is so perfect that this arc length along here is also 3 units long, so L is also equal to 3. Then what I've created is I've created such an angle here, theta, that is equal to 1 radian. So that's how we define what a radian is. So the next question that we have to ask ourselves is how many radians, so how many radians can I get in a circle? So how many radians are there inside of a circle, and how might we be able to work this out? Well, if we think of the radian as composing r units of length So the next question that we have to ask ourselves is how many radians are in a circle? So how many radians do we have inside of this circle? Well, we know that 1 radian, okay, as we've just seen, corresponds to taking up r units of the arc length. Okay, so the arc length here is r units long. Now, how many of those r units? So the next question to ask here is how many radians can we get into a circle? So how many radians in a circle? Well, another way that we might like to tackle this is think, okay, well, how many of these arc lengths can we get into this circle? If an arc length here specifically has to be the same length as the radius, then how many of those can we get around the circle? Because that arc length is corresponding to 1 radian. So if we break that down, how many r being the unit of length of the radius, can fit into the circumference of the circle? So our arc length is equal to r units long, that's our arc length. How many of those can we fit around into this circle? So what I mean by that is we could fit another one there, we could fit another one here, we could fit another one here, etc. How many of those could we fit around the circle? And that's going to tell us how many radians we've got inside of our circle. Well, first of all, we've got to think about, okay, well, how long is that circle's circumference? So the circumference part, well, we know that the circle's circumference is 2 pi r units long. So how many of these r's can we get into 2 pi r? Well, a simple division, we can see that we can get exactly 2 pi of them. So this is the important part that I really want you to remember, is that there are 2 pi radians in a circle. Okay, and we've just proved that a little bit with that demonstration that we just did before. But the main takeaway that I want you to get from all of that is that there are 2 pi radians in a circle. And what is 2 pi? Well, 2 pi is approximately 6.283. So we can get about 6.283 radians into a circle. And this is the main thing that I want you to remember. So what we have to do next is, based off of this information that we've got here, we need to be able to convert these guys into degrees. So we've just worked out that there's 2 pi radians in a circle. But we also know, a key piece of information which we do know by now, is that there are also 360 degrees in a circle. So what does that mean? Well, that means that 2 pi radians is equal to 360 degrees. These guys are the same. Okay, so what does that mean? Well, if I divide both sides by 2 pi, then I will see that 1 radian is equal to 360 divided by 2 pi degrees. Okay, and if I wanted to simplify that down a little bit, I could write that as 180 divided by pi degrees, or if you wanted to get that as an actual decimal, we see that 1 radian is equal to approximately 57.3 degrees. So 1 radian here equal to 57.3 degrees. So that's an important thing which you might like to remember. We can also work out, based off of this information, if I was to divide both sides by 360. So I see that 2 pi over 360 radians is equal to 1 degree. And again, if I did my 2 pi divided by 360, I see that I get 0.017 radians is equal to 1 degree. So these pieces of information here, this one here and this one here, can help me convert my radians into my degrees. And the way that we worked that out was off of this really important piece of information. And if you're going to remember one thing from this so far, this is the bit which you should probably remember, that we get 2 pi radians is the same as 360 degrees. And that all comes back to this point, that we get 2 pi radians in a circle, and we know that there's 360 degrees in a circle. What we're going to do now is we're going to take these 2 pieces of information here and sort of this guy, which is where it all came from, and we're going to just look at practicing a couple of conversions from radians into degrees. So we'll come down here. So what did we just work out? We knew that 2 pi radians, we know that that's equal to 360 degrees. Okay, so that's one piece of information. And then we did a little bit of rearranging, and we saw that 1 radian was equal to 57.3 degrees, and we saw that 1 degree was equal to 0.017 radians. Okay, and I've got a few practice problems which we can have a go at here. So we'll start off with what is 20 radians, and trying to convert that into degrees. So 20 radians into degrees. Well, if 1 radian is equal to 57.3 degrees, then 20 radians would be 20 of those. So we need to do 57.3 degrees times by 20. And if you pop that into a calculator, you will get 1,146 degrees. Secondly, we're going to look at, for example, maybe it's 3 radians. So the exact same, we know that 1 radian's 57.3 degrees, so we know that we need to multiply that by 3. And when you do that, and again, pop it into a calculator, you get 171.9 degrees is the same as 3 radians. I'm just going to zoom out a little bit now to give us a tad more room. Finally, question 3, just for the radians section, we're going to look at what pi radians is. So we're actually looking at about 3.14 radians now. Well, what happens here? Well, I could just do my 57.3 times pi, and if you put that into a calculator, you're going to get very close to 180 degrees. But if we want to get that in a more sort of exact way, okay, maybe a more mathematically correct way to kind of work that out, well, let's go back to this piece of information, that we know that 2 pi radians is equal to 360 degrees. So that's this piece of information up here, remember. So if I want pi radians, I need to divide both sides by 2. So I see that I'm now dealing with 180 degrees. And that's probably a better way to tackle that sort of question than potentially risking some rounding errors, which you may come across if you're using these decimals. So that's how we can work out radians into degrees. In a very similar way, we can go from degrees into radians. So we'll come over here, we can look at maybe what 3 degrees is. So we're going to have to multiply our 0.017 by 3. And if you do that, you end up with about 0.051 radians. Okay, second of all, we can look at doing 200 degrees. So again, I know that 1 degree is this many radians, so I multiply that number by 200. And if you pop that into a calculator, you get about 3.4 radians. Finally, question 6, we're going to do a similar one to sort of what we explored down here. I'm going to look at 90 degrees. Okay, now again, I could do my 0.017 and multiply that by, not multiply that by 90, multiply that by 90, my apologies. So I could do my 0.017 and multiply that by 90, and I will get 1.53 radians. Alternatively, if I want to be a little bit more precise, because I see that this 90 is it perfectly goes into this 360, right? It goes in there exactly 4 times. So if I take this piece of information, 2 pi radians is equal to 360 degrees. Well, if I want to work out what 90 degrees is, I can see here I've done a division by 4. So if I do the same on this side and I divide by 4, I end up with pi over 2 radians. So I could write it as 1.53 radians, or I could write it as pi on 2 radians. And we're going to start to see potentially in some later videos that being able to write these radians as exact values of pi, and sort of exactly what we're seeing down here as well, is going to be quite an important skill. Finally, the last thing that we're going to do discussing radians in degrees is see what impact this has on our unit circle. So if we pop a unit circle in here, okay, and we'll do it nice and big, and a unit circle kind of sits like this, and we go from 1 to -1, and we do the same on the y-axis. Now, I'm going to label the degrees of my unit circle in a nice blue pen here. So we've got 0 degrees where we start off, we come up to 90 degrees, around to 180 degrees, to 270 degrees, and then back around to 360 degrees. Now remember that we worked out that 360 degrees was the same as 2 pi radians, okay, because we know that we can get 360 degrees in a circle, and we worked out that we can get 2 pi radians in a circle, so we know that they're the same. So if I was only to go halfway around, so instead of going the full lap, what if I only went here? Well, I would only have half of this much which I've travelled, so I've gone 2 pi divided by 2, which is just pi. So I've only gone 1 pi, so this would be pi radians. So 180 degrees and pi radians, they're actually the same. Likewise now, if I think of just going from here to here as 1 pi radians, if I was to only go half of that way, then I've gone pi over 2 radians. So this would be pi on 2 radians. Likewise, if this going 1/4, the way around the unit circle is pi on 2, if I went another quarter, I would be up to pi, and if I went another quarter, I would be up to 3 pi on 2. So all we're doing is we're breaking this unit circle up into portions based off of just this piece of information that we know here. And as long as we know that this piece of information, then we can break up any part of this unit circle. For example, what if I was to come out 45 degrees? So I come out on this angle here. Well, this is 45 degrees here. Okay, so I've now only gone, I've kind of broken this pi on 2 now, I've broken that down into another half. So I'm now looking at pi on 4 radians. Okay, so you can kind of see how we're just breaking this 2 pi kind of portion of a circle up into different sections. Likewise, if I wanted to go maybe 30 degrees and I come out on this angle here, then my 30 degrees, I've now broken this 90 degrees up into 3 further slices. So I've now got pi on 2, but I've cut that up into 3 further slices, so I've now got pi on 6s. So this would be pi over 6 radians. And you can kind of work your way around the unit circle, and I'd encourage you to do that to try and sort of work out what the others might be. And we'll do one together. So let's say that I come out on this angle here, and we'll say that this is actually 240 degrees. So we'll say that this is 240 degrees here. Well, I can break this up into sections of 30 degrees. So I've got 30 degrees here. If I was to do another 30 degrees and then another 30 degrees, I would get my way back to kind of fill out this quadrant. And I know that they're not quite to scale, but just understand that they're all 30-degree portions. Now, I know that when I'm dealing with 30 degrees, I'm looking at pi on 6s. So how many of those 30 degrees to get around to 240? Well, I have to do one 30 degree, another one, and another one. So there's 3 in that quadrant. There's another 3 30 degrees in this quadrant, and I have to do 2 more to get to my angle of interest. So I've done a total of 3, 6, 7, 8. I've done a total of 8 of these pi on 6s. So this would be 8 pi out of 6. And you can simplify that fraction down to be 4 pi over 3. So that's how we can break this unit circle down into these different portions, converting these degrees into radians. And you don't have to remember them all. We've only got to remember this piece of information here. Now, where this video is going to go a little bit later on, maybe in a video down the track, okay, is we might need to now start to work out, now we know what sine of 30 degrees is. Now, we know from our exact values that that is equal to a half. But now I'm going to start to ask, okay, well, what if sine of pi over 2 radians? Okay, so we need to try and work out, instead of degrees, I'm going to give you exact values in radians, and we've got to try and work out what they would be. So we know that pi on 2, okay, we know that that is 90 degrees, so the sine of 90 degrees, and we know that the sine of 90 degrees is equal to 1. So you can work it out that way. And it's all going to come back to this fundamental understanding here of how we can break this unit circle up.